Here we have some problems about Venn diagrams. And Venn diagrams are these diagrams that use circles to show belonging to groups or sets. This first one says use the Venn diagram to find the probability that an element chosen at random from the diagram is in B but not in A. So we usually express probability as a fraction, and on the bottom is all the possible outcomes. And if we're going to choose some member here from this diagram, the all possible outcomes would be the number of members there are. So what we need to do is just add up all these numbers. Here's 1 plus 1 plus 1 plus 9 plus 6 plus 6 plus 8 plus these three down here who are not in A, B, or C, but hanging around outside. All of those add up to 35, I'm pretty sure. You may want to check my addition there. And then we need to find something that is in B but not in A. So this circle is B, and this little area right here, this 1 and this 9, that's also part of A. They overlap. So those are in A and B. We want just the parts of B that aren't in A. So this area is good, and this area is good, but the rest of that B is in A. So I've got 6 plus 6, that's 12. So my probability then is just 12 chances out of 35 that an element is in B but not in A. All right, let's try another one. This one, we have a word problem, and we really need to make a diagram to make this make sense. So let's see if we can try that. It says in a school of 450 students. So here's the school. That's the whole shebang. 81 students are in band, and 181 are on the sports team, and 41 are in both. So there's some overlap. Okay. So we're going to call this band and this sports. So we've got 81. Well, we've got 81 in band, but 41 are in both. So I'm going to put the 41 in here. And to figure out what number goes here, I have to take 81 minus 41. So that's actually going to be 40. So now the number of students in band is 40 plus 41. That's 81. That's what we've got. The number of students in both is 41. And then the number of students on sports team is 181. Again, I have to subtract this 41 from it. That would be 140. So you see, if we look at the circle of sports students, we'd get 41 plus 140. That would be the 181 that we've got there. So there's our diagram. Now it says how many students are involved in either band or sports. So they want all of this stuff. So we need to add 40 plus 41 plus 140. So 40 plus 41 is 81, plus 140 is 221. All right, and let's look at a couple of logic problems with Venn diagrams as well. This first one up here says sets A, B, C, and U are related as shown in the diagram. And really what this shows, before we look at the questions here, what this shows is that A, B, and C, they're all members of U because they're all inside this big box called U. A and C have some parts that are different, but they also have some overlap. And B doesn't overlap at all with A and C. So if you're in A and C, you're not in B. And if you're in B, you're not in A or C. So it says which statement can be made regarding the relationship among the sets, assuming none of the regions is empty. So we're looking for a true statement. A says no element is a member of all three sets A, B, and C. Well, that's true. We got lucky right off the bat. It's the first one. Because if there was a member that was an element that was a member of all three sets, B would have to overlap with both A and C for that to happen. But that's not happening here. Let's look at this next one. It says A, B, C, and U are related as shown. Now here we have a slightly different kind of diagram. A, B, and C are all members of U, the big box, and A overlaps with B, A overlaps with C, B overlaps with C, so they all overlap. So right here in the center, this would be someone who's a member of A, B, and C. All right, so which statement can be made? A says it's possible for an element to be a member of sets A, B, and C. Aha! That's what we just talked about right in here is where A, B, and C overlap. So we got lucky again. The first one was true. So that is a little bit of work with Venn diagrams.